Hi guys, welcome to today's video. I'm so glad once again to have David Udosen join me. Welcome, David.
Thank you, Dennis. Hi everyone.
Alright guys, so this is actually a follow-up of the mini grid design course series videos we drop daily, and if you have not checked any, do well to do so in the previous videos, and I'm very sure you're going to have a grasp of solar energy. Alright, so we'll be doing a concluding part of solar resources, and I'll be starting up David to take over, and it's sure going to be very insightful. Alright, so let's get started. So for solar thermal energy, it's simply harnessing the sun energy to produce either heat or electrical energy. Now for the heat, it could be within 65 to 70 degrees Celsius in its operation, or for the thermal energy or the electricity or the electrical energy, it could be between 150 to say 300 degrees Celsius. Alright, so for this we have the collectors, the solar circuit, and also the heat store. Now you need to understand that a collector could either be the flat plate or evacuated tube. But before I go through the explanation of this system, I will allow David to do justice to doping. Very important. Alright, David.
Alright, Dennis, thank you so much. So about doping basically is the introduction of impurities into the lattice structure of pure semiconductors, or what we know as intrinsic semiconductors. So basically, this arrangement, this bonding, actually creates what we call extrinsic semiconductors. And basically, there are two types of extrinsic semiconductors. We have the P-type or the N-type. The P-type is formed when group 3 elements are introduced into the lattice structure of a pure semiconductor, and they create a net positive charge. For the N-type, N is negative, so we have introduction of group 5 elements into the lattice structure, creating a net negative charge. Basically, that's it, Dennis.
Alright, thank you so much. So doping intrinsic semiconductor to extrinsic semiconductor. Thank you so much, David. Alright, so for the flat plate, like I said earlier on, we have the absorbent, we have the transparent cover, we have the frame, and we have the insulation. Okay, while for the evacuated tube, now what you need to understand about the evacuated tube is that it does not make use of the copper, thereby it prevents it from any loss due to insulation. Now what happens with the transparent cover and the frame is it prevents it from adverse weather condition. That is why for the evacuated tube, it has about a very high efficiency, more than the flat plate collector. Alright, so David, can you run us through photovoltaic effect, because we discovered that in a solar cell we talk more of photovoltaic effects.
Alright, so thanks Dennis again. So basically, PV effects or photovoltaic effects, like you just mentioned, is the conversion of light energy into electrical energy, or what you know as electricity. So basically, the sun's radiation carries photons of energy, and if this energy is sufficient enough, it can actually, when it strikes the panel or the solar PV modules, it can actually raise the electron, allowing it to jump from its valence band into the conduction band. And basically what happens here is that the electrons will stay there if they are close to the PN junction. Now, if they are not close to the PN junction, they could fall back, having what we call a recombination process. But if they are close to the PN junction, they can actually be transported from the P region to the N region. Now, an electron is moving from the P region to the N region, is creating a net negative charge in the N region now, and also because of the absence, creation of a hole in the P region is creating a net positive charge. Now, these two parts, these two potentials create a potential difference, as you know, of about 0.6 volts. Now, the accumulation of electrons on the N region and also the accumulation of volts on the P region is what creates voltage, which when a conductor is connected to it, creates electricity. That's about it.
All right, thank you so much. It might look complex, but you can do well to go over the video, and I'm sure you're going to get a good grasp of it. All right, so now we'll look at solar resources. Now you may ask yourself, what do we use to measure solar resources? Basically, we make use of a pyrheliometer and a pyranometer. What you need to understand basically is the major component in those two equipment I just mentioned is the thermopile sensor. Very interesting, right?
Thermopile sensor, don't forget that.
All right. So, David, you have something more to say?
Yeah. Okay. So basically, it's just to understand the effects of irradiance and also the effect of temperature on the production or the efficiency of the solar cell. So first, you must understand that there is the solar cell, the solar PV module do not require so much radiation of the sun.
Yeah.
So it has little or no effect. The greater the temperature does not really affect the performance or the production of solar electricity from PV modules. But on the other hand, we have the effect of, what was that, temperature?
Yeah, temperature.
The effect of temperature.
You just put up the radiance.
Yeah, so the effect of temperature. So when the temperature increases, the solar cell becomes more conductive, but also the electric field becomes slimmer, and so the potential difference gets smaller. So in net, when it powers the production of current and voltage. So because the voltage depletes to a sufficient amount, we have a low efficiency. So temperature is not the best of things for solar cells. So the lower the temperature, the better your solar cell performance.
Yeah, thank you so much. Now, rounding up, now you must have heard of CSP, which is the generated solar power, and the solar photovoltaic. Now, the major difference is for the CSP, it actually beams sunlight to the receiver, okay, through a reflective concentrator, while for the photovoltaic it converts sunlight to electrical energy directly, and most times CSP is located in the tower. Alright, so thank you so much, David.
Thank you.
I really appreciate it. Thanks for coming around, and I'm very sure you must have learned so much today. Keep it on check on this dial, and do well to check the previous videos if you have not done so, and anticipate the next video. Massive thanks to the boss Anedi, All On Energy, GIZ, NESB,
European Union, and GEES. Thank you so much.
Alright, see ya.